I want to take a look at the shape of some exponential functions. We've already seen the shape of a few of these curves. Let's start off with y equals 2 to the x. I'll use x as my independent variable when we're drawing right now. We could have just as easily used t. So let's plug in a few points. If x is equal to 0, 2 to the 0 is 1. If x is equal to 1, 2 to the 1 is 2. If x is equal to 2, 2 squared is 4. If x is equal to 3, 2 cubed is 2 times 2 times 2, or 8. If x is equal to 4, it's 16. These get big very quickly. If x is equal to negative 1, it's 1 over 2 to the 1, or 1/2. If x is equal to negative 2, it's a quarter. We already did this kind of plot in class. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. And I'm going to do this in what I think is blue. So if x is equal to 0, y is equal to 1. If x is equal to 1, y is equal to 2. If x is equal to 2, y is equal to 4. If x is equal to 3, y is equal to 8. If x is equal to 4, y is equal to 16. If x is equal to negative 1, y is equal to 1/2. At negative 2, we're at 1/4. At negative 3, we're at 1/8. And we have a very familiar shape here. Y equals 2 to the x. If we do y equals 3 to the x, so here's y equals 2 to the x. Here we have y equals 3 to the x. At 0, we're at 1 again. At 1, 3 to the 1 is 3. At 2, 3 squared is 9. At 3, 3 cubed is 3 times 3 times 3, or 27. That's already off the blackboard, so I'm not going to go any further than that. At negative 1, we're at 1 over 3 to the 1. At negative 2, we're at 1 over 3 squared, or 1/9. Negative 3, we're at 1/27. We can plot a few of those points. I'm going to plot them in what I think is pink. So it goes through the same point again. 0, 1, it goes through 1, 3. It goes through 2, 9. 3, 27. It goes through negative 1, 1/3, negative 2, 1/9, negative 3, 1/27. So it is below the blue curve over here. And then it goes above the blue curve over here. And I think you can see that the bigger the base, the faster this thing's going to grow to the right, and the faster it's going to shrink on the left-hand side. Now, and this is as close as we're going to get to calculus this semester. It turns out that if you look at the blue curve, the 2 to the x curve, and you draw on the line which just grazes the curve at x equals 0, the line which just grazes the curve there, that line has slope less than 1. It's about 0.7. And if you take the line, if you take the curve y equals 3 to the x, and you draw the line which just grazes the curve at x equals 0, that line has slope bigger than 1. It's I can't tell you exactly the number, but it's bigger than 1. So somewhere in between 2 and 3, there's a base I can use for an exponential which has slope exactly 1 at x equals 0. And that number is e. So y equals e to the x, I'll just draw that in white. So it's between these two curves over here, and then between these two curves over here. Y equals e to the x. If I go right to x equals 0 and draw the line which just grazes the white curve there, that line has slope exactly 1. E is a number between 2 and 3. E is approximately equal to 2.71. It's one of those constants that's inherent in the universe, like pi. It just keeps coming up in a lot of different contexts. So far, so good? I want to graph one more function for you. Before we move on to the next thing. Y equals 1/2 to the x. If I plug in power 0, anything to the power 0 is 1. And if I plug in x equals 1, 1/2 to the 1, that's a half. If I plug in x equals 2, 1/2 squared is a quarter. 1/2 cubed is 1 over 2 times 2 times 2, 1/8. Let's plug in -1. 1/2 to the -1 is 1 over 1/2. That's the number 2. If I plug -2, that's 1 over 1/2 squared. 1 over a quarter, 4. So I'll draw this one in white too. At x equals -2, we're up at height 4. At x equals -1, we're up at height 2. At x equals 0, we're at 1 again. At x equals 1, we're at height 1/2, then 1/4, and then 1/8. At -3, we'd be up here at height 8. This curve looks like this. And it goes down to the right. All these other curves went up to the right. So when we're talking about an exponential function, this number that's raised to the power of x, that's the base. Let's call that a. So y equals a to the x. A is the base. And a will always, always, always be a number greater than 0. If a is bigger than 1, the function grows to the right. We call this exponential growth. If a is smaller than 1, which means since it's bigger than 0, it has to be between 0 and 1. So if a is between 0 and 1, we have a function which is shaped like this. It shrinks to the right. And we call this exponential decay. When the base is bigger than 1, it grows to the right. When the base is between 0 and 1, it shrinks to the right. If the base is equal to 1, it's just a horizontal line at height 1. That's not particularly interesting. We already know how to give a function for that using simpler means. Now, we could do the same thing to these curves that we've done to just about any other curve. If I want to give something like y equals -1/2 to the x, negative 2 to the x. So the minus sign is outside the parentheses. You take your power first and then take your minus. Order of operations, powers come before plus and minus. So 2 to the x we know is this curve right here. That minus sign is just a reflection. The minus sign is outside. Outside we have a vertical reflection. We're just turning this thing upside down. So we're taking the blue curve and reflecting it over the horizontal axis. So what we have is something that looks like this. It crosses at -1. And so this curve right there is just that curve right there. We've just taken the blue curve and flipped it upside down.